So, hello team, here we are with the screencast for the hackathon that we are gonna organize at India offices, both Hyderabad and Bangalore on 22nd, 3 p.m. to 4 p.m. and it's gonna be real fun. Let me tell you, it's gonna be real fun. So right, let me quickly tell you about the actual game itself. So this game has this canvas. Okay, this is a multi-level game. For example, here what I can see is that there are 3 levels and I'm at level number 1. So in this game you have to move this robot, or I call it rat or something, this rat, and you have to eat the food that you have. Food is this dot that you see, blue dot that you see. Okay, on a canvas you don't have to have only one blue dot, one food. You can have food in many places. Okay, so your aim is to move this rat and eat the food. So simple, right? So now how do we move the rat? To move the rat, Move understands simple English-like language. That is, it understands when you say S, it understands that it has to move straight. So let me run this. Yes, it is very intelligent. It's understanding what it is supposed to understand. Right. So now, apart from S, it also understands 2 more characters, that is L and R. L to turn left and R to turn right. So L, let me see what happens. It turned left. Now R, let me see what happens. It turns right, right? So these are 3 simple instructions that our beautiful rat understands. Okay, S, straight, move straight. L, turn left, or R, turn right. Okay, when you turn left or right, you do not go to the next point. You are at the same point, only changing the direction, right? Okay, great. Now with this new simple language, let us see how we can dictate this rat to eat that. So I have to move, as you can see, I have to move 2 steps, 2 steps straight, SS, and then I have to turn to the left. Okay, and when you turn to the left, you are not changing a step, you are on the same step, you are only changing the direction, and then you have to say SS. Okay, let us run this. Straight left, and there you go. Congratulations, you have completed this level. You are successfully eating the food that was there on the canvas. So looks great. Let me submit, and on the server my score goes up. Right. So now this is very simple, right? What's the fun? Why is this gonna be that fun-filled event, right? So the actual thrill of this event comes when you try to use less and less number of letters and get the work done. Now what do I mean? What I meant is, this rat or this game gives you the power to define your own letters. Okay, let me try to demonstrate it with one better example. Let us say that I want to eat all these dots. Obviously this looks like a square, right? And the side 1 2 3 4, 1 2 3 4 5 6. Okay, so I have to move, say, SSS 4 5 6 times, and then right. Okay, if I do this, I just complete one arm of this square, so I have to complete the other 4 arms also, right? So that's how I eat the whole square. Okay, but what happened? I ate all these dots, but I don't get that congratulations message. What happened exactly? You know, this level says that you cannot use more than 20 bytes. So each level has a maximum number of letters that you can use. Here I have used like 6 S's, 1 L, that is 7. 7 I used 4 times. So 7 into 4 is how much, man? 7, 14, 28. I had calculations, I guess. Right. So right. So now so this is not acceptable, right? So how do I really achieve this? To get these kind of things done, we have this capability of looking at the repetitions and defining our own functions out of that repetition. So what I meant by that is, I can define my own function called A. It can be any small letter, A, B, C, A to Z. Okay, it has to be a small letter. Function name has to be a small single letter, not multiple letters. Okay, and I can say what this means. A means I have to move 6 times S. I can say anything, right? 6 or okay, 6 times s and l, okay. And so here I have defined my function, and here I'm asking it to execute that function. So let us see if it does that. Yes, it does that. Okay, but it has to move right, not left. So right, so here it is. Okay, but this is not enough, right? I have to do this 4 times. 1, 2, 3. Oh, I mean 1 already. So 4 times. As you can see, I was able to complete it in less number of bytes this time, less number of letters this time. Okay. So not only this, your functions, you can even pass parameters to your functions. For example, I can pass some parameter called m. Okay. For example, what I will do is I will use this parameter and repeat this a 4 times. How to do it? Okay. So this n is 4. So you will do this, and then you can call this a again. That is nothing but recursion, right? But this time you will pass 3 to this a. That is 1 less than what it got. So you will pass 3, then that becomes 2, like that. So let us see if this really does that. Yes, it is doing that 4 times, right? Even I can do this 3 times. So 3 times, right? What's happening here is, first it says a of 3, so it does this SSSR, then it sees a of n minus 1. So here n is 3, so a of 2 gets invoked. Okay, a of 2, then a of 1 get invoked, then a of 0. Any moment, if any of the parameters are 0 or less than 0, then you come out of the recursion, right? So right there, so that's the way you can come out of a recursion. Recursion is nothing but a function calling itself again and again, okay, calling itself. And one more thing about this hackathon is that you don't only have to send numeric parameters. You can even send some parameters that are instructions themselves. For example, let us say that I want to do this. I want to pass these instructions as a parameter. I can always do that. So this function takes 2 parameters, n and m, where n is a number, a number, and m is the set of instructions, and it does that instructions and then does recursion. Okay, to the recursion it passes m as it is, but reduces the count by 1, so that you come out of the count. If I see, so there you go. So you are able to do this 3 times, right? You can do it 2 times or whatever, right? Not only that, see, you don't have to always pass what was given to you. You can always modify the instructions also. You can append to m, you can append let us say SSSR. Okay, so you will get, I will reduce this. Let us say I will reduce this to SR. Okay, and here I will add some SSS to. So it will be SR, SSSS, then SR, whatever 3 SS, then 3 more. Every time it appends 3 SS in every recursion, right? So in that way you will get some crazy kind of pattern kind of stuff. So let me see. Okay, so using this power of passing both numeric and the instruction parameters and defining your own functions, you can always achieve any pattern of food that you are going to see on the canvas in the maximum allowed number of bytes, right? Now, so that's about all about the game, the rules. The next thing is about the score. So what is the scoring formula for this thing? So every level, you cross a level when you eat all the food. If you miss even one food, then you get score 0. That's obvious. But if you eat all the food, then we consider the number of bytes you have used. Okay, any letter A to Z, capital or small, is 1 byte. For example, maximum. See, as I'm typing, the count is going down here. Okay, so this helps you to know that how many characters in excess you have used. For example, here it says I used 10 characters in excess. One more. I know that I have to use only these many characters to get this done. So right. So coming to the formula, as I've said, the formula is nothing but each level will have a base score like 100 plus there will be offset, like every byte that you save. Okay, for example, if it is a 20 byte level and if you use only 19 bytes, that means you are saving 1 byte. So for every byte that you save, you will get 10 points more. So if it is 20 byte maximum bytes are 20, and if you used let us say 18, then you save 2. That means you will get 2 into 10, 20 points more. That is, you will get 100 base points plus 20. So the person who completes the level by default gets the base points 100. Then the person who saves more and more, uses lesser and lesser bytes, will get more and more points on top of that base score. So now, let me, for this game, it is very important you should understand very clearly what one byte is. One byte is any letter A to Z. It can be S, L, R, or your own functions like A, B, C. Okay. For example, as I write this, okay, you can see the countdown going one byte down. Okay, and also note that a number, okay, for example 123, this is only 1 byte. Okay, what you can see here is it has only reduced by 1 byte, because numbers like 123, 100, 200 are only 1 bytes. Even single digit number 1 is a 1 byte. Okay, whereas AA is 2 bytes, two characters, right? So any single character is 1 byte, A to Z, capital or small, and any number 123, 100, 200, okay, even though it's a 3-digit number, it is still 1 byte. Okay. So let me see how many bytes this is. Colons are not bytes. Okay, they do not consume any bytes. Even this parentheses are not bytes. Okay, only letters and numbers are bytes. For example, if I say 123, this whole 123 is only 1 byte. Okay, so this is 1 byte, this is second byte, this is third byte. So right, folks, this is how, this is what the game is, and be prepared to, to see all the beautiful patterns on the canvas, which will take your imagination to complete different level, not only in seeing the patterns, but also coming at par with how you think in terms of recursion. Okay, so folks, for all, see you on 22nd, 3 to 4 p.m. for all the fun. And before I go, I would like to just show you the home page that you're going to see. We will give you the URL. So this is how the page would be. So right now practice sessions are up. You can just go and play, and on 22nd, and you can register. Right now register is not working, not in place, but that will be in place soon. Once register is in place, you can go and click on compete, and you can create your teams. Each team will be of 2 members. You can decide whom you want to team up with. You can invite him via mail, and that guy accepts it, and then you become a team. Each team can have maximum 2 people. So yeah, that's it. So let us see. Let's meet on 22nd March, 3 to 4. Bye bye. Oh.